Assalamualaikum warahmatullahi wabarakatuh. First, we're gonna do the simulation first by using the SPSS. So this the variable rotational speed is independent and torque is the dependent variable. So we're gonna use the scale, and the scale also and role is input. So this data view, we put the data 100 data in here, the 100. So first output, we need to find the mean, median, mode, variance, and minimum, maximum, and sum. Also, we're gonna use the frequency. So for the frequency, we analyze this statistic, frequency, and put the rotational speed and torque also. Statistic, a mean, median, mode, sum, and acceleration, variance, minimum, maximum, as mean. And after we continue, after we click the OK, we get the output like this. So after that, for next simulation, we're gonna find the graph. So okay, for the graph, we click the graph and check builder, click OK, and click the scatter dot. First graph in here, and this top is at the y-axis and rotation speed at the x-axis. And for the title, we can change it at custom. And so y versus x, top versus rotation speed. After we click OK, we get the output like this. So after that, we will find the regression. So for the regression, we analyze and click the regression linear. After dependent is the torque, and independent is the rotational speed, and click the statistic. So after that, we click this all and continue. And after that, after we click the OK, we get like this. Regression, statistic, correlation variable, model summary, ANOVA, coefficient, collinear diagnosis. Next, for the next simulation is t-test. So t-test, we have t-test 0 and t-test 1. So analyze, find the t-test, one compare mean, one sample t-test. Rotational speed and torque also. Option is 95%. So 0, we're gonna do two simulation which 0 and 1. After that, we click OK, we get this output. This is 0 and this is for the 1. So next, for calculation with the Excel. So this our calculation in here for define SSY as t-test also are in here. So our simulation for second simulation we use the Excel. Okay, that's all for the simulation. Thank you.
Present for the mean distribution, minimum and maximum value. So for the comparison for rotational speed, SPS and Excel get the same value for the mean and distribution. For the mean is 1561.4946 and distribution is 209.119. And for the top, also for the origin for SPSS and Excel is also the same. For the mean is 38.85 and the standard deviation is 9.51. So this is independent variable for rotational speed. So the mean is for the manual calculation is 205.11 and variance for independent variance stated variance is 42,073. Standard deviation is 205.11. Minimum value is 1,300. Maximum value is 2,678. And for the dependent variable, so the mean is 38.85, variance is 90.69, standard deviation is 9.51, minimum value is 10.70, maximum value is 63.9. And for the scatter diagram, so it shows the scatter diagram for rotational speed against torque. The set 100 set data, and the equation is y equal to negative 0.04 x plus, and the bracket 1.01 exponent 2. This can be concluded that as the value of rotational increase, the value of torque increase. So the diagram below show the linear relation between the value of rotational speed against star. So this is the graph. So for assuming the linear relationship is the least square method to find a simple linear regression model. So here we got here. So for xxy is negative 1.66988, xxx is 4165308, xy is 8968. For the beta 1 is negative 0.04, beta 0 is 101.44, and in y for the complete is 101.449. So here is a table for coefficient table. So that's all for me. Thank you.
The next part is use the least square method to find the simple linear regression model in 3.3. The least square method based on model in 3.3. It is a linear relationship square method. It must known value sum of x, y, xy, x square and y square. The equation for regression line is y equals to negative 0.04x plus 1.01 times 10 to the power of 2. The value of p for rotational speed is 101.4495569, while negative 0.040094401 is the constant, which is intercept of y. The significant value is 0.000, which is less than alpha 0.05. So we can conclude that the slope is significant. And the next part is interpret the meaning of intercept and the slope. The model for simple linear progression is given by this equation, where we can get the graph of scatter plot rotation speed via stock. The y represent dependent variable, x represent independent variable, beta output represent y-intercept, and the epsilon represent the statistical error. The slope is 101 and the intercept is negative 0.04. And when we interpret the negative slope, the explanatory variable increases and then the response variable will decrease. And for the next part, we have to test the hypothesis whether the slope is equal to 1 or against unequal to 1 by taking 5% level of significance. Table 3.6.1 tabulates the one sample statistics, while table 3.6.2 tabulates the one sample test that had been obtained by using the SPSS software. So the computation of MSC and t-test is shown below. The value for SSC is 2274.038104. For MSC, 23.20447045, and t-test 1, it is negative 440.66530078. Since the t-test 1 is less than 1.984, we can conclude that the slope is equal to 1.
Okay, now I'm going to talk about the coefficient of Pearson correlation and the interpret of the meaning. So this is, you can see the correlation table here of the Pearson correlation for the torque and rotational speed. So for this coefficient of Pearson correlation, we calculate it by using this formula and put the value, and the result we got is in negative, which is negative 0.863971653. So from this we can conclude that the correlation is negatively strong linear relationship. Okay, next I'm going to talk about the table 3.8, which is the tabulate model summary. So the coefficient determined R square is used to measure the statistical analysis. When the coefficient is higher, the higher percentage will pass through the line. R square is used as a guideline to calculate the accuracy of the statistical analysis. So rotational speed in RPM give the proportional of the other variable torque in Nm. So as you can see, we use this formula and get this value here, 0.746447017, and by square root it we got this value. So this proved that the strong linear association and the 74.64% of the total variation is explained by the regression line using the independent variable. Okay, so as the conclusion, there are 100 set of data we collect to complete the data analysis from the internet resources we get it. And from the slope, we can see that there is a weak negative linear relationship between the rotational speed and torque for machine predictive maintenance. And while for the Pearson coefficient correlation is R equal to negative 0.863971653, which prove that the correlation is negatively strong linear relationship. So students are able to analyze the data using the statistic package for the social science SPSS software. And that's all from us. Thank you.
Pikachu!